These are notes for objective 1.10, graph a piecewise function. This is on 9/11. Before we can graph piecewise functions, we need to learn a little bit about inequalities, and we can practice that here. Assume that this is the x-axis for both of these. An inequality can be used to describe this line that starts at one number and continues forever in another direction, but only one direction. This number represents this line represents all the x's that are -1 or bigger. So we say x is greater than or equal to -1, and that's our inequality. Over here, this one is x is less than or equal to -3, because it takes all of -3 and the numbers less than. And this one, x is greater than or equal to 0. Any number that's greater than 0 or 0 is included in that line. So you need to remember that as we do piecewise functions. Now a definition. Piecewise functions are functions that have different equations in different sections of the graph. So piecewise functions are functions that have different equations in different sections or domains of the graph. When we graph one, you're given an equation something like this, and this is called piecewise notation. This particular piecewise function has two parts, one part and two parts. The first part, y equals 4, is a part y equals 4, tells you the equation, and then the inequality here tells you in which domain this equation operates. So y equals 4 only when x is less than or equal to -3. And y equals -3x plus 15 only when x is greater than 4. To graph this, you need to write out both equations. So y equals 4, that comes from my first one there. And I put its inequality above it, when x is less than or equal to -3. And then y equals -3x plus 15. But only when x is greater than 4. Now that we have both equations written out, we need to make a table in order to graph them. And I'll go ahead and start here. So x and y, x and y. When I have a table, I need to pick some x values. The first x value you should pick is always the one from your inequality. So we have x is less than or equal to -3, pick -3 as your first x value. Then we need another x value, you always need 2, and pick another one that satisfies this inequality. So any x that's less than or equal to -3, and -4 would be perfect. -4 is less than -3. We now need to find the y values, and to do that, you take your x values and plug them into your function. The function here is y equals 4. So if I take y equals 4, and I need to put in -3 and -4. Now in this particular equation, y equals 4, there is nowhere to plug in those x values. So we just know that y is always equal to 4. When you have just y equals a number, y always equals that number. Go ahead and graph those points. -3, 4, and -4, 4. And then take your ruler and graph the line. Now normally you would go back and forth over the entire graph, but in this case you start at your first point, which was -3, 4, and you continue, in this case, to the left, like so. Continue to the left. Now there are a couple of reasons why we go to the left. One, we started at our first point and we went towards our second point. That's one reason to go to the left. The other reason is that x here is less than or equal to -3. And the less than side is to the left. So we've got -3, -4, -6, -9. Those are all numbers that are less than -3. And then the other way, the little trick, is to look at the inequality, and it makes an arrow that's pointing towards the left, so you know to move towards the left with your line. We'll do the same thing over here for this equation now. Pick two x values and plug them into the function to find the y values. Remember always to pick the x value from the inequality as your first one, so 4. And then another number that's greater than 4, like 5. Here, we plug these x's into that equation. Y equals -3 times 4 plus 15, which is -12 plus 15, which is 3. So I go ahead and I put that in there. And then do the same thing with 5. Y equals -3 times 5 plus 15, which is -15 plus 15, which is 0. Go ahead and plot those points. 4, 3, and 5, 0. And draw your line. Remember to start at your first point, which is in this case right here, and this time we're going to move towards the right. And again, there's a couple of reasons why we know to move towards the right. We're moving towards our second point there. We're going to the greater than side because x is greater than, and to the right is the greater than side. Or we're following the little arrow here, which means go to the right. That is your piecewise function. Two separate pieces governed by different equations in different sections of the graph or different domains of the graph. One thing that's important to note here is that this line right here should have an open circle at the end. Now, I forgot to put an open circle there, but you can see that I've done one now. And the reason we know that is because x is only greater than 4, not greater than or equal to. If it's greater than or equal to, like this one, you have a closed circle. But if it's only greater than, you have a open circle. So flip it over. We'll try another one on the back. So again, write out both equations. Y equals 2x minus 5 when x is less than or equal to 1, and y equals 2 when x is greater than or equal to 3. Those are my two equations, this one and this one. Make yourself a table, x and y. I'm just going to make a table for this one for right now. The first x value should come from your inequality, 1. The second x value should also come from your inequality. Any number that's less than 1, we'll say 0. And then to find your y values, you plug these x values into the equation. Y equals 2 times 1 minus 5. 2 minus 5 is -3. Same with 0. Y equals 2 times 0 minus 5, which equals -5. Go ahead and plot your points. 1, -3, 0, -5. And draw your line. Start at the first point, right here, and draw towards the second point. Or start at the first point and go to the left because the arrow points to the left. Now, with this one, we have y equals 2. You could make yourself a table if you wanted to, but you don't have to. When you see y equals a number, you should know that that means a horizontal line at that number. So a horizontal line at 2. Y equals a number is always a horizontal line at that number. Now we're not going to draw the line across the entire graph, but instead we're going to start at the x value that we're given in the inequality. So x is greater than or equal to 3. So we go ahead and we start at x equals 3, which is right here. And I put a dot, and then I continue in the direction that the arrow tells me. So in this case, to the right, like that. And there's your graph.